anytime you're working around live lines, of course, you have to assume that there's a potential for contact. Overhead wires can carry a much greater current and voltage than, say, a standard 120 volt service in a home or a business. Higher voltage almost always translates into higher danger potential. Even with proper personal protection equipment, acting with caution is always the best way to stay safe.
Just because a bucket truck has rubber tires doesn't mean you can't be hurt by an energized line. Birds can sit on a live wire and not be shocked because they don't complete a path to the ground.
But unfortunately, you can. That's why techs who their stuff use the back of their hand to move wires that could be energized, because if they grab onto a charged line palm first, the muscles in their hand could contract and make it absolutely impossible to let go.
So yes, electricity can really mess with your muscles. And since the heart is one big muscle, that's the reason an electric shock can stop a heart. Our body uses tiny amounts of electricity, which is how our nerves transmit sensations to the brain and how the brain itself issues commands. A jolt of 120 or 240 volts with enough current can really mess that up in a person.
Actually, if we were a perfect conductor, electricity would simply pass right through us. But because the body is just a good conductor and not a great one, an electric shock usually results in burns from the heat that our body's resistance creates.
Now, before we leave the subject of ways you can be hurt by electricity, we have to mention that safety rules weren't created just for you. Ignoring the basics or taking shortcuts can potentially harm our customers, our equipment and facilities, random bystanders, and even your coworkers. The extra few minutes you take before, during, and after a job to be safe is important. It's because we want you coming home to your family every night.
Now, you might not have ever thought about this, but do you know why we use AC or alternating current and not direct current or DC to power our lights, businesses, and homes? Anybody? Huh? The answer to that question has as much to do with politics as it does physics.
In the late 1800s and into the early 20th century, most electric lights and industrial engines were powered by direct current or DC. Direct current was safer than AC or alternating current. It was easier to produce DC with early generating technology, and businesses that had converted from steam engines to electrical power for their plants were heavily invested in direct current.
But direct current had a major drawback. You see, DC generators had to be within a mile or two of where the power would be used, since it got weaker as the distance increased. Now, that was fine in big cities, but it made bringing DC power to rural areas almost impossible. Also, direct current voltages couldn't be increased or decreased easily using transformers. On the other hand, alternating current gave power producers the ability to distribute power over very long distances. And because transformers could step up and step down AC voltages, the copper lines needed for an AC power grid didn't need to be as large or as expensive as the lines for DC voltage. Now, after a battle that raged on for years and was fought by all the electrical pioneers like Westinghouse and Tesla and even old Thomas Edison, the less expensive and more versatile AC distribution method, which could also bring power to the entire country, was adopted in the United States and throughout most of the world.